Okay, what we're talking about today is going to be chapter 2, and we're going to be chapter 1, section 2. We're going to be talking about functions and what it means to be a function. Okay, so the very first thing you need to know is a function is a relation that assigns an element x in set A exactly one element y in set B. What this means is, if you are in set A, you have to choose one element from set B. 1 is choosing 5, 2 is choosing 7, 3 is choosing 8, and 4 is choosing 5. All of set A must be used, but not all of set B has to be used. Okay, to be a function, each element of A must be used, but not all of set B has to be used. Now, this is kind of an important example for me to give. It makes sense to people whenever I use this example. So, if I would say in here how many people want ice cream versus how many people want candy, okay? The ice cream and candy example is this. If I bring in chocolate and vanilla ice cream and I say, who in here wants ice cream? Everybody votes and everybody says they want ice cream. You are going to choose either chocolate or vanilla. As soon as somebody chooses none, we're no longer a function. You have to choose one or the other, okay? If you choose ice cream and candy, you're a double dipper and you no longer can choose. You can no longer be a function. You have to choose either ice cream or candy. You cannot have both. It's kind of like a relationship. Okay, 1 and 2 can choose both ice cream. 3 and 4 can choose both candy. That's okay. But 1 cannot choose both ice cream and candy because it's like a cheating boyfriend or a cheating girlfriend. You with me? Okay? So all of set A must be used. X is the X values. They cannot repeat. If the X values repeat and they choose two different Y values, then they are not a function. So you're always going to ask yourself the question, did my X values repeat and choose two different Y values? If that is the case, then it is not a function. The domain is all the X values, and the range is going to be all the Y values. Domain X, range Y. Domain X, range Y. Domain X, range Y. You're going to hear me say that over and over again. So, is the following a function? All I care about is going to be my X values. -2, 0, 2, 4. Did my X's repeat? No, my X's did not repeat. They are all unique numbers, -2, 0, 2, 4. My X values did not repeat, so yes, this is a function. Okay, next one. -1, -1, 0, 2. Did my X values repeat? The answer to that is yes, they did repeat. -1 chose +1, and -1 chose -1. Meaning, this is a double dipper. My X is repeated. So no, this is not a function. X values cannot repeat and go to two different Y values. Okay? Now let's talk about function notation. Function notation is super duper easy. Function notation is y equals f of x. That is function notation. Y is what you knew back in Algebra 1. F of x is what you knew in Algebra 2. Then f of x equals g of x, which equals h of x. Those are all different functions. This is you, this is your mom, this is your dad. Okay? All it's saying is that you just have different functions. F is one function, g is a different function, h is a different function. Then, the way you read this, f such that x implies is the same thing as f of x equals y. It's just kind of a fancy way to say that it's a function. I like to use this example. Whenever you first are born, you call your mom, mom, or mama, mama, daddy, whatever. Then, as you introduce people to them, mom and dad turn into, let's say, my name is Kendra, so I turn into Kendra. However, if I'm being introduced to somebody that I have no idea who I am, then I'm Mrs. Yoder. Okay? This is mom. This is Kendra. And this is Mrs. Yoder. I'm still all the same person. It's just a fancy notation. It's still the same thing. It's just saying why. All right, evaluation of a function. I give you f of x equals 3x minus 2, and I want to know what f at negative 5 is. This is a simple plug and chug. I am plugging in and replacing x with negative 5. So this gives me negative 15 minus 2, which is negative 17. So what this literally means is that you have the ordered pair negative 5, negative 17, which is really something your brain needs to grasp. Next, I want to know what f at negative 4 of I want to know what f at x minus 4 is. So same exact thing. I'm replacing x with x minus 4. So if I distribute that, that's 3x minus 12 minus 2, which is going to be 3x minus 14. When I plug a number in, I get a number out. When I plug an expression in, I get an expression out. Okay? Next, I want to know what f at 5 minus 7x is, so that's going to be 3 times 5 minus 7x minus 2. So that's 15 minus 35x minus 2, so that's going to be 13 minus 35x. Nothing new, all the same information for you. Now, this is number 9 out of the textbook. So if you open your book to page 24, the directions say, in exercises 9 and 10, which set of ordered pairs represent functions from A to B? Explain. Well, here's A. A is the set 0, 1, 2, and 3. Set B is negative 2, negative 1, 0, 1, 2. You have to use all of set A every time, but you do not have to use all of set B. So here's the question I have for you. 0, 0, 1, 1, 2, 2, 3, 3. Did I use all of set A? Yes, I did. So since I know I used all of set A, what this now means is I now have to ask myself, did any of my x values repeat? So that's 0, 1, 2, 3. None of them repeated. So now I need to know, are the y values that have been chosen in the B set? 1 is in there. Negative 2 is in there. 0 is in there. 2 is in there. I didn't use the negative 1. Is that okay? Sure it is. Not everybody is going to choose every type of ice cream flavor in Baskin-Robbins. There's going to be some that are not going to be chosen. That's okay. The question is this a function? Yes, it is a function because none of my x values repeated and I used all of set A. Letter B, 0, negative 1, 2, 2, 1, negative 2, 3, 0, 1, 1. First thing, 0, 2, 1, 3, 1. Did my x values repeat? The answer to that is yes, my x values repeated. 1 chose negative 2 and 1 chose positive 1. Is this a function? No, it is not because my x values repeated. Okay? Next, 0, 1, 2, 3. Well, 0, 1, 2, 3, I've used them all, and they all chose 0, and none of them repeated. Is that legal? Absolutely. You and your family can go get ice cream, and every single person can choose chocolate ice cream. That's totally fair, and yes, this is a function. 0, 3, 1. 0, 3, 1. My x values didn't repeat, but did I use all of my set A? What I am missing from set A is I'm missing the value 2. 2 was not used in this scenario, so that means no, not a function. 2 was not used. Okay? So not all of set A was used. So that is how you're going to do problems 9 and 10 in tonight's homework. Okay, so that brings us to the next thing, which is problem 31. Problem 31, the directions say, in exercises 27 through 38, evaluate the function at each specified value of the independent variable and simplify. You are always going to hear me read the instructions to you first, and the reason why is because you guys need to learn how to read the instructions and understand what it's asking for. Evaluate is another word for plug and chug. Evaluate the function at each specific value. So they're going to give you a value, and you have to calculate it for the independent variable and simplify. So 31, f at y is equal to 3 minus the square root of y. Well, instead of f of x, they're using the variable y. It's totally fine, not a big deal. So we're just going to go ahead and we're going to say, okay, we're going to plug in 4 for y. So that's 3 minus the square root of 4. The square root of 4 is 2 to give you 1. Okay? Same thing here. 3 minus the square root of 0.25. My brain automatically says that that is 1/4. If that's 1/4, I divorce my numerator and denominator, and I take the square root of both of those. So that's going to be 3 minus 1 over 2. $3 minus 50 cents is going to be 2.5. Okay? Now, on tonight's homework, you'll notice that I said to only do A and C. So you do not have to do letter B on any of these. Next, number 35. Number 35, the function is f of x equals the absolute value of x over x. So again, you're just plugging and chugging. So this is going to be the absolute value of 2 over 2. Absolute value is the distance in numbers away from 0 on the number line. So the absolute value of 2 is 2, so 2 divided by 2 is 1. Okay. Next, 37, f of x equals, this is a piecewise function. A piecewise function is going to be a function that has pieces and parts put together to make one big function. What this means is I'm going to use 2x plus 1 function for all the values for when x is smaller than 0. You know what this means? It means I'm using this when x is negative. Sorry, I wrote positive. When x is negative. However, I'm going to be using 2x plus 2 when x is greater than or equal to 0, meaning I'm using it for all the positive values. Okay? So f at negative 1. Do I use the top green function or do I use the bottom pink function? Well, negative 1 is less than 0, so that means I'm going to be utilizing the 2x plus 1 function. So I simply plug and chug. 2 times negative 1 is negative 2, plus 1 is negative 1. Same exact thing. I want to do f at 0. So if I'm doing f at 0, is 0 going to be what compared to 0? It's equal to it. So since 0 is equal to 0, I have to utilize the part of the function where it is equal to, which means I'm using the 2x plus 2 part. So I'm just going to simply plug in 0 for x, and 0 times 2 is going to be 0, plus 2 is 2. Okay, that is a piecewise function. Next, the directions say for 39 through 42, it says complete the table. Guys, this table is an XY table. Remember the XY tables used to look like this, and you just simply completed the table. This is still plug and chug. This is still plug and chug. So I'm going to have 1/2 absolute value of negative 5 plus 3. So that's 1/2 times the absolute value of negative 2. The absolute value of negative 2 is 2. And half of 2 is 1. So 1 goes there. Going to do the same process all over again. So 1/2 times the absolute value of negative 4 plus 3. And that's going to be 1/2 times negative 1. The absolute value of that is going to be positive 1. And half times 1 is going to be 1/2. That goes there. Then you're going to go and do the next one. 1/2 times the absolute value of negative 3 plus 3. That's going to be 0. The absolute value of 0 is 0. What's 0 times anything? 0. That goes there. And you would continue on and doing this, okay? 45. This says find all the real values of x such that f of x equals 0. Find all the real values of x such that f of x equals 0. What this means is you're replacing f of x with 0. So that means 0 is equal to 3x minus 4 over 5. Put this over 1 and simply cross multiply. 0 times 5 is 0. 1 times 3x minus 4. So that's cross multiplying. So I have 0 is equal to 3x minus 4. 4 is equal to 3x. So 4/3 is equal to x. Tonight's homework is going to be section 1-2, bookwork 1, page 24, 1 through 9, odd, And then 27 through 45, odd, A and C only. Okay? Because you have parts A, B, and C, and I only want you to do A and C. If you have any questions with this, please let me know. Be sure that you are labeling your paper. Be sure that you are writing your period on there, and that you are writing the book assignment, and you're showing work for every problem and writing the problem down. Thank you. Have a great day.